Hello, my name is Jacob, and this is Lab 2, which is tape treated as a line charge instead of a point charge. So the purpose is to observe the interactions of two charged tapes to create a computational model of their electric forces on each other, to find the charges of the tapes and compare them to Lab 1, where they were treated as a point charge. As a point charge, they were found to be 1.587 times 10 to the negative 8 coulombs, and as a line charge, we found them to be 2.9876 times 10 to the negative 8 coulombs. The fundamental principles that we need are Newton's second law. An object's acceleration is proportional to net force, where if net F net equals ma. Coulomb's law, which calculates the force and direction between charged particles or bodies, which is the hefty equation that you see below, and these variable definitions. So the initial conditions, because it was the exact same experiment as before, was the tape mass was 0.0002 kilograms, the tape length was 0.2 meters, the tape width was 0.02 meters, the system was tape B, and the surroundings were primarily tape A and everything else, mostly air. And the distance between them was 0.034 meters. So this was the point charge model, where it has all of our details outlined and it shows what the graphs look like. And this is all just a review of what was in the last lab. And then this is the line charge model, where we treated it as a bunch of different points on an axis. So I chose n to be 50, so we're basically looking at 50 different point charges and all of their interactions instead of just one point charge on the tape. And then this is just the rest of the starter code to create this picture on the right. And so we received that the magnitude of the electric force was 1.96207 times 10 to the negative third, and the magnitude of the gravitational force was 1.962 times 10 to the negative third. These were all that was used for the computational model calculations, or the electric force has to be equivalent to the magnitude of the gravitational force, and then we found what Q was, which came out to be 2.9876 times 10 to the negative 8 coulombs. And the magnitude of the electric force and the magnitude of gravitational force are listed again, just as last slide. To compare the models, the point charge model had a force of 1.587 10 to the negative 8 coulombs, and the line charge had 2.9876 10 to the negative 8 coulombs. In these models, we assumed that friction and air resistance were negligible, that the tapes had identical magnitudes of charge. In Lab 1, we assumed that they were point charges, and in Lab 2, we assumed that they were evenly distributed line charges. And in the computational model, we could only represent the line charge with a bunch of different points. So the error could have come from different charges in the tapes. The mass of the tape was calculated and not measured or official, and other surrounding forces were not considered, on top of the fact that we couldn't adequately measure the force. We just had to do it by a bunch of different point charges. So if we had modeled each of the tapes as a single point charge, like in the previous lab, as previously stated, we would have 1.587 10 to the negative 8 coulombs, and which is obviously different from the line charge model. And these estimates differ because there were entirely different methods of calculation, and the line charge is much closer to the real model because it takes into account length of the tape rather than simplifying it to something that it's not, like a single point charge. And that is all. Thank you.